Again, welcome to our Unit 5 lectures. In this lecture, we are going to discuss about multiplication and also division of polynomials. This is a college algebra course. So our main objective is multiply polynomials, how to rationalize the denominators, and also divide polynomials. So we start with the multiplication of polynomials. Now, to multiply polynomials, for example, if we have two monomials, we just multiply the coefficients and also their variables together. What we mean is that if I have, let's say, 6x, it's a monomial, times 7y. The answer will be 6 times 7, and also which is 42, and x times y, which will be sy. So the answer will be 42xy. Now, to find the product of a monomial and a polynomial, then all we do is multiply the monomial by all the terms of the polynomial. This is using the distributive property. So in other words, to multiply a polynomial by a monomial, we multiply each term of the polynomial by the monomial. And we're going to see an example. Before that, let's discuss about special product formulas. Now, if we have x plus y all square is the same as writing x squared plus 2xy plus y squared. Now, when we have x minus y squared is the same as x minus y times x minus y, which will give us x squared minus 2xy plus y squared. Now, when we have x plus y times x minus y, it will give us x squared minus y squared. So difference of two squares always will give us x plus y times x minus y. So 3 examples are shown in this table. Squaring a binomial sum. So if I have x plus y all square is the same as, again, you can multiply x plus y by itself twice. Or if we can remember, first square the first term plus multiply the first and second term with 2. So we get 2x and y. Then last we square the last term, which is y. So x squared plus 2xy plus y squared. Now, example is given here. If I have 4x plus 7y all square, I'm not going to multiply all the terms. You can write 4x plus 7y times 4x plus 7y. Then we multiply all the terms by itself. Otherwise, we can use the formula, the perfect square. So what I'll do is that I'll square the first term. 4x will be 16x squared. That's what we have here. Secondly, I'm going to multiply 2 by 4x and 7y. So I'll get 2 times 7, 14 times 4 will give me 56 times xy. So we get 56xy. Then lastly, I'll square 7y, which will give me 49y squared. The same thing applies to squaring the binomial difference. This is the formula again. So I have this term. So what I'll do is that from the formula x minus y all square means square the x, the first variable, then multiply 2 with the two terms, x and y, by use the minus. Then square the last term. So this means the answer here will be 25x squared minus 2 times 5 is 10 times 9 will give me 90. So 25x squared minus 90xy. And that's what we have here. Then lastly, we square the last term, which will give us 81y squared. Then the next we have the sum and difference of two terms. This is again difference of two terms. So if I have 11x plus 3y times 11x minus 3y, then the answer will be 11x squared minus 3y squared. That's what we have, 11x squared minus 3y squared, which will give us 121x squared minus 9y squared. This is normally called the difference of two squares. So how do we multiply polynomials? The most common method we always use is called the FOIL method. F stands for the first terms. We multiply the first terms. O stands for the outer terms. I stand for the inner terms. Then the last term we multiply. So let's see an example here. I have x plus y, x squared minus xy plus y squared. So we have multiplied this term. So what I'll do here is I'll multiply x by x. Again, it doesn't matter. I can multiply x by everything and then y by everything. Then we combine the like terms. Or in this case, I'm going to multiply x by x squared, which will give me x cubed. Then x by minus xy, which will give me x squared minus x squared y. So first, x times x squared is x cubed here. Then x times minus xy will give me minus sy minus x squared y. Then x times y squared will give me plus xy squared. Then I'll move to the second term, y. Y times x squared will give me x squared y. Then y times minus xy will give me minus xy squared, which is, and the last term will be y times y squared, which will give me y cubed. Now let's combine the like term. I have s squared y is minus, and also I have plus s squared y. So they will cancel. S squared y minus plus s squared y, they will cancel. Then I also have x y squared plus minus xy squared, so they will also cancel. So our final answer will be x cubed plus y cubed. Now let's try the second one. We have x plus 3 all cubed. So I'm going to break it down into two first, x plus 3, then x plus 3 square. Then I'll find the square. We know this is, again, perfect sum square. So I'll square the first term, x squared. Then I'll multiply 2 by x and y, which will give me 6x. Then I'll square the last term, 9. Now I'm going to use the distributive property. I will multiply x by everything and also 3 by everything. So s times s squared will give me s cubed. S times 6s will give me 6s squared. S times 9 will give me 9x. Then 3 times s squared will give me 3s squared. 3 times 6x will give me 18x. And the last will be 3 times 9, which will give me 27. From here, we combine the like terms. We have only one s cubed, so I'll leave it. We have 6s squared and also 3s squared. Both are positive, so we get plus 9x squared. Then we have x and x. Both are positive, so 9 plus 18 will give me 27x. And only one constant variable, which is 27. So that will be our final solution. S cubed plus 9x squared plus 27x plus 27. This is another example here. We can use the for method. We can use the distributive property as we did previously. So I'll multiply 2x by 5x and 8x. Then I'll multiply 3 by 5x and 8x. That's what we write here. 2x plus 3. 2s plus 3. 2s times 5x plus 8 plus 3 times 5x plus 8. So from here we get 2s times 5x will give me 10s squared. 2s times 8 will give me 16x. 3 times 5x will give me 15x. 3 times 8 will give me 24. Then we combine the like term, which is right here, 16x plus 15x. And that will give us 31. So we get 10x squared plus 31x plus 24. And that will be our final solution. Now we're going to use the for method. But the for method, we should always remember, it's only used when we are multiplied two binomials together. So a good example would be y plus 3 times y plus 7. If it's y plus 7 times, let's say y plus 7 plus y squared, that would be a trinomial, it's not a binomial. So we can't use the for, we use the distributive property. Use y to multiply everything, use 3 to multiply everything. So what we mean by the for method is that first we're going to multiply the first term, which is y times y. So y times y will give me y squared. Then I will go to the inner terms. So the inner terms will be 3 and y. So 3 times y will give me we have y square already. So we have 7 times y and 7y. So we multiply the outer. After the outer, which is y and 7, then we go to the inner. The inner will be 3 and y. Then the last term, which will be 3 and 7. It's the same as using distributive. So y times y is y squared, y times 7 is 7y, 3 times y will give me 3y, then last 3 times 7 will give me 21. You get the same answer. But the first saying the first term, y times y will give me y squared. Then the outer will be y times 7, which will give me 7y. Then the inner, 3 times y, which will give me 3y. Then the last term, 3 times 7, which will give me 21. So finally, our answer will be y squared plus 10y plus 21. We should remember that, again, the for always is used for only when we have binomials. So we multiply the first terms first, the outer term, the inner terms, and the last term. Here we cannot use the for method because we have trinomial, x squared minus 5x plus 4. So we use distributive. You cannot use for because they are not both binomials. So we must use distributive property. So I'll use the 2s to multiply everything, x squared minus 5x plus 4. Then I'll use minus 5 to multiply everything, x squared minus 5x plus 4. And that's what we have here. 2x times x squared minus 5x plus 4, then minus 5 times x squared minus 5x plus 4. So let's open the parentheses. We get 2x cubed, then 2x multiplied by minus 5x will give me minus 10x squared. 2x times 4 will give me 8x. Minus 5 times x squared will give me minus 5x squared. Minus 5 times minus 5x will give me plus. Minus times minus is plus. 5 times 5 is 25 and x. Then minus and plus will give me minus. 5 times 4 is 20. Now let's see if we have a like term. So we write down the 2x cubed. That's the only one we have. We have 2x squared minus 10x squared minus 5x squared. So we get minus 15x squared. Then we have plus 8x plus 25x. So that will give us plus 33x minus 20. So this will be our final solution, 2x cubed minus 15x squared plus 33x plus 20. Now let's go to rationalizing denominators. We quite remember at the beginning of our lectures, we talk about if we want to rationalize anything, in this case, again, it can be an expression, or algebraic expression. All we need to do is to remove the radicals. Rationalize means remove the radicals. So an example is given here. You can see here we have radicals. That's why we say we're going to rationalize the denominator. Now remember, anytime we have something like this, square root of 3x plus square root of 2, my goal is to square both sides. We know square will cancel the square root, so that will remove it. In order to do this, then we remember the formula for the difference of two squares. So if I have a square root of 3x plus square root of 2 multiplied by square root of 3x minus square root of 2, my answer will be square root of 3x all squared. So that means I'll have only 3x, square root cancels square. Square root of 2 all squared, so square will cancel the square root. So the answer will be 3x plus 2. And that's what we are trying to do here. The question gets that we should rationalize this. So we write the question down. You see that we have multiplied both sides by what? The minus. So we can get difference of two squares. So square root of 3x plus square root of 2 multiplied by square root of 3x minus square root of 2. That will give me 3x minus 2. Now, anything you do to the denominator, we have to do the same thing to the numerator to balance the equation or the expression. So in this case, we have to use the square root of 3x minus square root of 2 at both the numerator section and the denominator. Now we do our distribution here, square root of 3x times square root of 3x minus square root of 3x, square root of 2, then minus square root of 2, square root of 3x, Then minus square root, minus times minus will be plus. So square root of 2 times square root of 2. And that's what we do here. So what I'm doing at the numerator is that I'm using the distributive property. I multiply square root of 3x by square root of 3x minus square root of 2. And I multiply minus square root of 2 by square root of 3x minus square root of 2. This will give a difference of 2 squares. We can see the terms are the same. One is positive, one is negative. So that's a difference of 2 squares. So that's why we get square root of 3x all square minus square root of 2 all square. And as we know, square root and square will cancel each other. So finally, we get 3x minus 2 at the bottom. When we combine this, square root of 3x times square root of 3x, that will give me only 3x. Square root of 3x times 2 will give me square root minus square root of 6x. Then here we have square root of 2, square root of 3x, so that will give me square root of minus 6x. Then square root of 2, square root of 2 will give me square root of 4. Square root of 4 is 2, so we get 2. And then we can combine minus 6x and minus 6x again. So that will give me minus 2 square root of 6x. Combining the like term here, 6x, 6x. So our final solution will be 3x minus 2 square root of 6x plus 2 divided by 3x minus 2. Now we move to polynomials division. Most of the time we do the polynomial division by long division method. Also, we can use what we call the synthetic division also. So for example, we have 2x squared plus 11x minus 30 divided by x plus 7. It's better to write it in this form, x plus 7. And then, so this will be a long division method. Now we call the x plus 7 as a divisor. And 2x squared minus 11x plus 30, we call it the dividend. Then the answer that we get is called the quotient. Normally the answer will be at the top here. So dividend will be the value, the numerator value. Divisor is the denominator value, is dividing. And the solution we get is called the quotient. So let's see this example here. We have minus 3x cubed minus 3 plus 7, x to the power 5 plus 4x squared minus x to the power 4 by x squared minus 3. So if I want to solve this problem, the first thing I'm going to do, this will be our dividend. So I'll put it in this form and I'll divide by x squared minus 3. And that's what we did here. Again, you can see the term change a little bit. Why? We write the highest degree of the term first. So s to the power 5 first, then minus s to the power 4, then minus s 3s cubed. Then we have square plus 4s squared. That's what we did. So the question here is the same thing here. Now, how do we do the divisor? We have to be careful. Take the first term, which is s to the power 5, and divide it by the first term of the divisor. So s to the power 5 divided by x squared will give me s cubed. Then I'm going to multiply s cubed by the divisor. So I'll get s cubed times s to the power 2, which will give me s to the power 5. Then s cubed times minus 3 will give me minus 3s cubed. Now you can see that we left a space here because the like terms, we are arranging it vertically the same term. Now you'll find the difference between the dividend and what we just write right now, which is s cubed multiplied by s squared minus 3x. Now this will give me minus s to the power 5, positive s to the power 5. So they will cancel. Negative s to the power 4 is by itself, so we bring it down. Then minus 3s cubed, minus 3s cubed. The down one will change to positive because we are subtracting. So that will give us 0. Then we take the next term. So now we have negative s to the power 4 plus 4s squared. The same thing we do, use the first term, divide by the first term here. So minus s to the power 4 divided by s squared will give me minus s squared. Then multiply minus s squared by the divisor again, which will give me minus x squared times x squared will give me minus x to the power fifth. Minus and minus will be plus now. 3 times x squared will give me 3x squared. Then we combine it again. This will minus, so minus x to the power 4 you have changed to positive, so they will cancel. I'll bring the minus 3x cubed. So here we have 4x squared. This will be minus also, it's plus, so it will be minus. So the answer will be x squared. Then the last term is minus 3. Now x squared minus 3 divided by x squared minus 3 will give me 1. And the remainder is 0. So our final solution, which is our quotient, will be x cubed minus x squared plus 1. Now, if you want to make sure the answer is correct, multiply x cubed minus x squared plus 1 by x squared minus 3. You should get the dividend. It should be the same answer. So let's see if you can get one more example. So this is arithmetic long division. If I have 277 divided by 12, 12 can go into 27, is 2. 2 times 12 is 24. 27 minus 24 is 3. Then I bring the next 10. 12 can go into 37 is 3. 3 times 12 is 36. 37 minus 36 is 1. So that's the remainder. The step here is the same thing we are doing for polynomial long division. The only thing is that in polynomial long division, we have more than one term here. So this means we have 2x squared plus 7x plus 7 divided by x plus 2. So what I'll do is I'll take the first term, 2x squared, I'll divide it by x. The answer will be 2x. Now 2x times x will give me 2x squared. 2x times 2 will give me plus 4x. Then I'll write minus at the down. So 2x minus 2x will be 0, they will cancel. 7x minus 4x will give me 3x. I'll take the next step, which is 7. Now I'm going to divide 3x by x. That will give me 3. 3 times s, that will give me 3s. 3 times 2, that will give me 6. So the remainder is 1. So dividing using a long division again. Step 1, say write the dividend in standard form, including a test with coefficient of 0. We don't have no y, but we just put 0y. We have 2x cubed minus x squared plus 0y plus 25. Then step 2, write the division in the same way as you when you are dividing numbers. And so we write 2y cubed minus y squared plus 0y plus 25. So now you take the first term, 2y cubed divided by y, and that should give me 2y squared. Then I'll multiply 2y squared by all the divisor here, y minus 3. So that will give me 2y cubed minus 6y squared. And that's what we have here. Then we put minus, we are subtracting from the dividend. So 2y cubed minus 2y cubed, they cancel. Y squared, this minus will turn to plus 6y squared. So the difference will be positive 5y squared. We bring the next term, which is 0y, and then we do the same thing. 5y squared divided by y will give me 5y. 5y times y will give me 5y squared. 5y times minus 3 will give me minus 15y. Then we find the difference. This will cancel 5y minus 5y. This is plus, so 15 plus 0 is 15. And the last term is 25. Now we divide 15y by y, we get 15. 15 times y is 15y. 15 times minus 3 will give me minus 45. And that's what we have here. Now looking for the difference, 15y will cancel 15y. And this will turn to positive. So the remainder will be 70. Here we can't go no more because there's no more variable. We stop when the variables are finished. If, for example, the difference here is 7y, then I'm going to do the same thing. 7y divided by y will give me 70. Then 70 times y, 70y, etc. So this will be our conclusion. We have final solution will be 2y squared plus 5y plus 15, remainder 70. This is another example again. So that was the question, and that's the solution. So again, I wish everybody the best. These lectures cover the multiplication and also division of polynomials, and also how to rationalize polynomials, especially the denominator polynomials. Most importantly, we should know the formula for difference of two square, sum perfect square, and also difference perfect square. Wish everybody the best. Thank you.